Yep, that's fine with me.
So let me welcome everyone to the X Zoom meeting. I don't know what it is because I was asked at the last minute yet again to host. So this is all improv now. I'm riffing. Be sure to mute your microphones if you're not actually actively trying to speak. A reminder to everyone on the Zoom call that we have, sorry, letting someone else on. We have our picnic in a week and a day. There will be another email going out about it tomorrow as a reminder. We have about 30 people registered so far. And I guess I will pass it over to Swapna now to introduce our guest speaker. So Swapna, take it away.
Okay, thanks, Alan. Well, welcome everyone to our June speaker night. We are very honored to have Dr. Samantha Lawler at our speaker night tonight. She's going to be giving a talk on the impact of megaconstellation satellites on astronomy. She joins us from University of Regina. So from a time difference perspective, she's 2 hours behind us. That's why so much light coming into her room, where the sun sets in the GTA. As usual, we encourage questions and answers. We have a chat. We'll monitor the chat. We'll make sure your questions are answered. So please feel free to add your questions there. Just in terms of introducing Dr. Lawler, she studies the orbits of the Kuiper Belt objects, exoplanets, and dust disks using optical and IR observations and dynamic simulations. She completed her undergrad degree at Caltech, followed by 2 years there working with early Spitzer space telescope data, and then earned a master's degree from Wesleyan University. Sorry if I mispronounced that. She completed her PhD at UBC, a postdoc at University of Victoria, and then a Plaskett Fellowship at NRC Herzberg, all while raising children. So that's awesome, and getting slowly drawn further into farm life with her partner. Somehow magically, she's found an amazing balance, and she's now an assistant professor of astronomy at the University of Regina and lives on a 150-acre farm where she helps raise goats, chicken, and grows organic vegetables with her partner and kids while enjoying and trying to protect the huge prairie skies. So thank you very much, Dr. Lawler, for joining us tonight. Over to you.
Thanks for inviting me. Thanks to all of you for coming. I'm gonna share my screen here. Let me start off by just apologizing because this is going to be a really depressing talk. I'm sorry, but I'm going to try to. So at the end, we'll come back and talk about. So what can you do about this problem? Because it's not set in stone. There's still a lot that we can work to change. Yeah, just so I will try to. I've done a lot of teaching on Zoom now, so I'll try to keep an eye on the chat. If you have a question while I'm talking, feel free to put it in there. And if I can answer it easily while I'm presenting, I will try to do that. Okay, so thanks. Let's talk about what's happening to the night sky. So I just want to start off with a very general introduction, right? Astronomy is the science of, it's basically when we look up at the sky, we see a pattern and we make a prediction based on that pattern, right? And this is something that humans have been doing and building structures to help us do for thousands of years. I would argue this is part of what makes us human. So it's really an important part of us as a species. I want to acknowledge the traditional knowledge of the sky from Indigenous people in Canada specifically. So I'm speaking to you today from Treaty 4 territory, the land of the Nahiawak, Anishinaabeg, Dakota, Lakota, Nakota, and the Métis-Michif, all of who have important cultural heritage and active cultural practice associated with stargazing. So I'm a settler, so I'm not qualified to talk about this right now. And those of you who are also settlers, a couple of really good resources to learn more about this Indigenous traditional knowledge. There's this fantastic book by Wilfred Buck that talks about Cree Indigenous knowledge of the sky, and it's just absolutely incredible. Like, there's so much in there that is completely compatible with modern quantum physics and the multiverse, and it's amazing, absolutely incredible stuff. And then nativeskywatchers.com is a really great resource for learning about a whole bunch of different, mostly North American Indigenous cultures and their knowledge of the sky. So I point you to those resources to learn more. So now in astronomy, we have more sophisticated tools, but we're still doing the same thing, right? We're looking for patterns. The patterns that we're looking for now are exoplanets transiting in front of distant stars, or magnetic field lines around a black hole, or near-Earth asteroids when they're going to come back again. But the goal is still the same, right? We're looking for these patterns, we're making predictions, and we're avoiding catastrophe. Now the catastrophe we're avoiding is possible near-Earth asteroid impacts, whereas it used to be the catastrophe we would avoid is famine from looking for food at the wrong times, right? So this is all this is continuing part of what makes us human. So we've already lost a lot of access to the night sky because of urban light pollution, right? Most people, the vast majority of people in the US and Europe and Canada live under light polluted skies. I thought that, moving here to the prairies, that everyone would have a good relationship with the night sky because so many people grew up on farms. But like, when I asked my astronomy 101 class, how many of you have seen the Milky Way? Less than a third of them raised their hands. It's horrifying. So like, this is a serious problem. People are not learning about the sky because of this light pollution. And this is something that has gotten rapidly worse in the last few years because of a sudden leap in technology, right? LEDs are super efficient. So that's fantastic, right? They produce more light with less electricity. That's important. But because they're cheap, they're super overused. And so light pollution has gotten much, much worse. A lot faster than people predicted. So there are groups like the International Dark Sky Association. I know there's a committee within the National RASC that's focused on light pollution. They've been doing great work, but this caught a lot of them off guard. And this is very similar to what's happening now with satellites. This is another leap in technology that's suddenly making a different type of light pollution really bad. And we astronomers are struggling to catch up with that. So we're fortunate here in Canada that we have access to a lot of good dark sky preserves. So in Ontario, I'm not as familiar with what you have in Ontario, but looking at the map, it looks like there's quite a few that are within not too terrible driving distance, right? You can get out of the city and get to a dark sky without too much trouble, right? Fortunate here in Saskatchewan. So where I live, I'm well inside the light dome from Regina. I'm in the light green part of the circle. But I can see the Milky Way from my back door, which is amazing. Like, I've never lived anywhere where I could do that. So I moved here in 2019 and I noticed satellites immediately. And I had noticed that there were more of them and they were increasing noticeably. And I started hearing about Starlink and I wondered, how is this going to affect things? And that's how I got sucked down this rabbit hole. So what is happening to the sky? Private company SpaceX is launching batches of 60 satellites into low Earth orbit. I say every 2 to 3 weeks, but they've launched 300 in the last month. So they're really hitting it hard lately. So there's currently 2,405 Starlink satellites in orbit. They have a huge failure rate. They're built fast and cheap, and that's right? So SpaceX built a reusable rocket. So all of a sudden it is much cheaper to launch so many satellites. This is the number of satellites over time. You can see how it has dramatically shot up in the last couple of years. So Starlink now owns almost half of all active satellites. By the end of the year, they will own more than half of all active satellites, one private company. Space, like there's all this language, all you see in like the early space race days, especially, space is supposed to be shared for all mankind, right? This is not shared. SpaceX already has permission to launch 42,000 satellites. That's almost 10 times as many satellites as have ever been in orbit before by one company. This is a nice visual made by Chris Van Eyck. So now the area of the rectangle is showing you the relative proportion. And this is from a few months ago. So it's actually, Starlink is actually a larger fraction now. So Starlink, as of February, was 36% of all satellites in orbit, right? The rest of the US owned satellites is less than a quarter, right? The rest of the world, right? The global north, 22%, the global south, the entire global south, less than 5%, right? This is clearly not at all equitably shared between countries, right? There is one company that is totally hogging orbit right now already. Okay, so why is this happening? This is happening to provide internet access, right? And all of us who during the pandemic can totally appreciate how important this is, right? Like I absolutely require good, fast internet to do stuff like this, to talk to you guys, to teach my classes, right? For my kids to do school during the pandemic, right? So I totally understand why there's this huge demand for it. And so you hear a lot like, well, this is going to bring global internet. Everyone can connect to Starlink. It's worldwide, right? But if you look at how much it costs, so this is how much Starlink internet costs compared to GDP, right? So how much money people have in a whole bunch of different countries. Right, saying, okay, well, you probably don't want to pay more than 5% of your total income for internet, right? And then this axis is the fraction of people in each country that already have access to the internet, right? So places up here, already a huge fraction of the people in the country has access to the internet. The countries down here are ones where not very many people have access to the internet, but it's also too expensive for people to pay for Starlink internet in those countries, right? So the part of the graph where it's needed is over here, where a country has very few people already connected to the internet, and they can afford it. So there's no countries in that part of the plot, right? This is not designed to bring internet to the world. It is designed to bring internet to places that already have good internet access. So, it's important to keep in mind, these companies like SpaceX, Starlink, Amazon, like they are not charities. They are very profitable companies. They are doing this for profit, not as a charity. So keep that in mind as we go forward. So it is a useful service, but they're not charities. Okay, so SpaceX I'm going to focus a lot on Starlink because they are the fastest and the first to be doing this, but there's a whole mess of other companies from many other countries that are lined up to do the exact same thing. So in order to claim part of orbit, all you have to do is get permission from, there's an international body that regulates radio broadcasts, and you have to get permission from whatever country you want to broadcast to. So like Starlink is basically just for Americans at this point. They also are broadcasting to Canadians, but their market is Americans. So they just had to get permission from the US Federal Communications Commission, right? They are not designed to regulate orbit. They are designed to regulate radio broadcasts. So this is terrible, right? The craziest example is Rwanda. which to my knowledge has no active space program currently, they have filed for more than 300,000 satellites, which is either a joke or some kind of brilliant political move to point out how stupid this system is right now. So anyway, so there's a lot of other companies that want to do the same thing, but I'll probably complain a lot more about Starlink because they're the ones I see right now. Okay, so what is the problem? These satellites are very reflective. I'm sure all of you have seen satellites in the sky, right? It looks like a star that's moving. And they are high altitude, so they reflect sunlight long after the sun has gone down. So we've crossed this transition point now, right? Like it's the example I use a lot is it's like the first cars, right? If you saw a Model T driving down your road, 120 years ago or whatever, you would run outside and watch it drive by, right? And that's how I used to be with like the space station. I would look up when it was going to pass over and I'd watch it, right? But now it's like living next to a giant highway, right, full of cars, the Trans-Canada, right? It's like there's satellites everywhere you look constantly. There's no rules about brightness. There's, I think, as far as I know, rocket launches are regulated by individual countries, not by I don't think there's any sort of oversight. And if there is, it's probably the US military, right? Not actually any sort of international body. So there's no rules about how bright these satellites can be, no rules about what orbits they can be on. It's really quite, I don't like to use the Wild West analogy, but like that is pretty much the best description of what's happening right now. Okay, so how bright are they? So I'm going to talk a bit about magnitudes. Some of you are probably very familiar with this. Some of them some of you might not be. So it's this archaic unit of measure that we astronomers love for the brightness of stars. And basically what you need to know is that numbers lower than 6.5 are what you can see with your eye without a telescope. So 5 is like, you could see that from a somewhat light polluted place. 4 is, you could see that from a light polluted suburb easily, right? So this is where all the original Starlink satellites were that were first launched, and astronomers yelled a lot about that, right? They were very bright, very easy to see. All of them are brighter than, bright enough that you could see them with your naked eye easily. So at first, SpaceX actually did try to retrofit some of their satellites. First, they tried basically painting part of their satellites black to reduce the reflections. That caused the satellite to overheat and die, so they did not continue doing that. Then they added visors to their satellites. They've had a big fanfare about like, oh, we're working with astronomers, we're making it darker. They have not put those on their latest generation of satellites because it interferes with the communication between the satellites now that they're using lasers instead of radio. So that's gone too. So so we're back to, so this is, the visors did work. They did get them fainter, but we're back over here for the next batch that launches. So just to point this out, right, even with the visors, more than half of the Starlinks were still naked eye visible. They had said that they would get down to 7th magnitude, which is sort of set by the Vera Rubin telescope. That's the brightness that if the satellites are brighter than that, that actually causes problems within the camera and won't just ruin where the satellite flies through, but will cause problems for the whole image. So SpaceX has said that they will get below that. They have not at all. This is what they look like. I'm sure some of you who do astrophotography have pictures like this, right? You set up your camera and point at a spot on the sky and just leave the shutter open, right? And you're going to get lots of satellites flying through. SpaceX, the Starlink satellites are kind of on a grid, kind of following each other. So when you have a long time exposure, you get this grid pattern going through your images. This is the same problem for research telescopes, right? But we get to use like really fancy, expensive cameras. So it's really a really big problem when we get these bright satellites flying through when you're trying to see something really, really faint. I hear a lot like, well, why don't you just send all your telescopes into orbit? Well, for one thing, we don't have, the JWST was $10 billion, right? We don't have that much money to make more of those. And these are from the Hubble Space Telescope. These are Starlink trails cutting through Hubble Space Telescope images, right? The Hubble Space Telescope is in the same orbit as Starlink, so it has the exact same problem. JWST is not in Earth orbit, so it won't have this problem. But again, we don't have many billions of dollars unless some billionaires want to donate to us, and they have not seen fit to do that yet. This is my data. I look for Kuiper Belt objects. This is my data from the CanadaFranceHawaii Telescope. So this is just a raw image. So these vertical lines are just bleeding from very bright stars. This diagonal is Starlink flying through. And here's more Starlink and more Starlink and more Starlink. And even on these little tiny thumbnails where, so I'm trying to find, these are Kuiper Belt objects, right? These little tiny faint things. They are millions of times fainter than a typical Starlink that flies through the field of view. So this is it's not causing serious problems yet, but it will soon. There's also been a lot of talk about these Starlink trains. I still haven't seen one. I don't want to see one, but I know that they have been seen from here. My partner has seen one. So when Starlink first launches, all the satellites are very close together and they're on a lower altitude orbit. So they are bright and they're so close together that your eye cannot resolve them. So it looks like a line moving across the sky. It is freaky. Right. And so, because of that, there was this amazing story in the New York Times about how like everybody's losing their minds. Everybody's seeing UFOs because of the pandemic. And it's not UFO. It's not because people are having mental health problems. It's because Starlink, right? That like I personally have gotten so many calls about UFOs because of Starlink. I'm sure many of you have had the same thing, right? If you imagine like if NASA was doing something like this, they would have people talking to newspapers all over the world, talking to universities, telling people what is happening. I went on a radio show in South Korea where they asked me about a UFO sighting in India, right? This is worldwide. Everyone in the world is seeing this, and SpaceX is doing nothing to tell people. It really annoys me. Okay, so I wanted to know how bad could this possibly get? So there's 4 companies that have made credible progress toward launching a lot of satellites. Comes to 65,000 satellites. So like a good academic, I turned this into a published paper because it just got bigger and bigger and like, fine, I want to find out how bad it's going to be and I want to do a good job. So let's do this. So this is 65,000 satellites, just a snapshot of where they would be at some moment, right? There's so many, you can't even see the continents underneath. We zoom in on North America, you'll notice there's these kind of denser bands, and that's just because of the orbits that have been chosen. And one of them pretty much goes right over me, which is really annoying. Okay, so now imagine that there's a globe in the middle of this sphere of satellites. So the sun is over here in this direction, lighting up the satellites. So back here, you'll notice there aren't satellites. That's because they're in the Earth's shadow. So they're not lit up by the sun. And then of course, this side of the Earth is daytime. So you're not going to see the satellites. So how many satellites can you see are lit up by the sun and in your sky? And so we can calculate that with this model. So this is latitude. So where you are on the Earth versus time of night. And then the color shows you how many satellites are sunlit and in your sky, right? So looking at, I don't know, you guys are at like 44 or something. So right at sunset, you've got like 3,000 sunlit satellites in your sky. And this will vary, but it'll go down to very few in the middle of the night, right? If you follow this across. But it depends on the time of year. Later in the summer, it doesn't go down very much, right? There's still thousands of sunlit satellites in your sky. So what does that look like? So the next step is to take those numbers and try to figure out how bright are the satellites going to be. And this is a lot harder to do because it depends on the shape of the satellite, it depends on the orientation, it depends on what it's made of. That's information that these companies do not share publicly because they're in competition with each other, right? So, so like good physicists, we decided to just say it's a sphere, right? This is like a standard physics thing, just spherical cow, approximate everything as a sphere, right? And you know, this is a terrible approximation, right? Like this is what a Starlink satellite looks like. It does not look like Sputnik, right? It is not a sphere at all. But we tried more complicated approximations and it didn't do a better job. So the spherical cow it is, right? And so we have this terrible equation, but it actually is not that bad. So this is just the brightness of the sun. This angle here is the phase angle. So the angle between you, the satellite, and the sun, right? How much sunlight is reflecting off of it. And then there's the distance between you and the satellite, right? And then there's one variable here where we change the satellite size and how reflective it is. And so that's how we calibrate this model. Yeah, do satellites ever collide? I will talk about that later in the talk. Okay, so now we have our spherical cow model. We need to calibrate it. So this was an all-Canadian team. We used data from a Canadian telescope because we were very interested in specifically like how is this going to affect us here at higher latitudes. So we took data from the Plaskett telescope in Victoria. We initially tried to only use visor sats because we were trying to be optimistic, and then we found out that maybe they weren't going to use the visors anymore. So we just used whatever flew through the field of view. So this is how we calibrate our model, right? So here's the magnitude again, right? So you'll notice that more than half of the satellites that flew through our field of view in the middle of the night in July were naked eye visible, right? They're still very bright. So we use this to calibrate our model. This actually gives us, this pretty realistically corresponds to an area of 4 meters squared, and albedo, so how reflective it is, of 0.2, which is like metal. So, you know, it's pretty reasonable without trying too hard. Our spherical cow model gives us kind of reasonable answers. So, okay, so now what do we do with this model? So there have been other works that have looked at this, but the numbers are changing so fast that the ones from even a couple of years ago are severely outdated. So we have our spherical cow model. We have the orbits that these satellites are going to be placed on that these companies have asked for. And we have open source orbital code. So how are the satellites going to move around the Earth? If any of you are coders, our code is all public. So Hanno Rhein is a big proponent of open source computing. So this is all here. There's also a web app. So this is a little bit, it's very easy to play with. And if any of you are Apple device users, Hanno has made a Megaconstellations app that does a little bit more realistic simulations of what the sky will look like with this many satellites. So that's a free app. Okay, so this is our calculation. So there's a lot of information here. I will walk you through it. So each of these circles is the whole sky, right? You know, that's straight up, and then west, north, east, south. The dots are satellites that are lit up by the sun, right? You see part over here, there's nothing there because that's the shadow of the Earth. Nothing's lit up there. And then the colors tell you how bright they are. So anything that is orange or yellow is naked eye visible. And that number is also here, the number that's visible, the number, and then the total number that would cause problems for telescopes, right? So then this is on the winter solstice, on the equinox, and on the summer solstice. And then this is just when it's starting to get dark, midnight, and just before it starts to get light. So this is showing you the distribution on the sky. So this is from Hawaii. So you can see that from Hawaii, where most of our research telescope, many of our research telescopes are located, at midnight, it's not so bad, even on the summer solstice. This is from 50 degrees where I am. So if you look at the summer solstice one, it's terrible. It's completely terrible. All night long, there are a couple of hundred naked eye visible sunlit satellites. I'm gonna skip showing these movies and I'm gonna show you yours. So this is Mississauga, so latitude 44. So yours isn't quite as bad. You get down to only a few dozen sunlit satellites in the middle of the night in the summer. Around the equinox, you'll get a couple of hours with no satellites at all. And in the winter, you have more time with no sunlit satellites. So it's bad, but it's not completely terrible. So here is a simulation. So this is on the summer solstice. It's the same latitude for you guys. You're close enough to Kingston. So here's, your all sky. Remember, anything that is orange or yellow is naked eye visible. The number is here. The total number of sunlit satellites in the sky is here, and your time is here. So this is just showing you how it moves forward in time. And so how many satellites are there depends on the orbits that have been chosen and on the season, right? So this will be different on the equinox than on the solstice. But you can see, like, they stay right at the zenith all night long. And, if you remember, there's actually only about 4,000 naked eye visible stars. So when you start getting up to a couple hundred naked eye visible satellites, that's significant, right? Like, 1 out of every 15 to 20 points in the sky would actually be moving. Think about how different that will look. That's where we're headed. Okay. And then, urban light pollution, you can get away from. There are dark sky preserves. This you cannot. Even if you go to the North Pole, there are a couple dozen naked eye visible satellites anytime that it is dark. There's nothing you can do to get away from this light pollution. Anyone in the world, whether or not you can afford to or are allowed to access Starlink, will have the same light pollution. It's really bad. Okay, so one of the things that there have been a couple of conferences between astronomers and satellite operators and space lawyers, the satcon meetings. One of the recommendations that came out of that was for lower altitude satellites. So that means the satellites will be brighter, but that means they'll be moving faster. So if you have, you're pointed at a spot on the sky, the bright satellite will move faster across your field of view and smear that brightness across more pixels. So the idea is that that will be less damaging. So we decided, okay, so let's take our model now and let's move all of the satellites out to either 1,200 kilometers, which is where OneWeb plans to operate, or 550 kilometers, which is where Starlink plans to operate. So this is different latitudes, right? This is on the summer solstice. And then these two rows are not right after sunset, and this is at midnight. So you can see that at the higher altitude orbits, there are fewer naked eye visible satellites than here, where there's hundreds. But it affects a larger swath of the world, right? It's more noticeable down to 30 degrees instead of just at 50 degrees. There's more fainter satellites in the sky, right? So the whole point of this exercise was just to show that there's no magic answer, right? You can't just say, oh, well, it'll be better for everybody if we move them to lower altitude orbits. Actually, if you're a naked eye stargazer, that's worse, right? And presumably if they move them to lower altitude orbits, they'll be moving faster and they'll want more of them to have the same coverage. So there's no simple solution here. The best thing to do is have fewer satellites. Okay. So that is most of what I'm going to talk about with light pollution. I have other things to focus on, but I just wanted to quickly pause and see if there's any questions about the light pollution aspect of these satellites, or anything I could clarify for anybody who's listening.
There's one question from Jennifer. With so many satellites in orbit, do they collapse?
So I will get to that in the next section of the talk. That's a good question. Are there any questions about the light pollution? If not, you can ask at the end. So, okay, so now I want to talk about the other problems that having this many satellites will cause, right? So remember this high density band of satellites. So another way of looking at it is number by latitude, right? So 50 degrees has this huge spike in the number of satellites over us. So that also means that we're going to be at the highest risk for satellites falling on us effectively. Space junk, any problems related to space junk will happen right over us here. So this is how many satellites are in orbit over time, but now broken down into abandoned rocket bodies. So like there's no rules about like, oh, you launch something, you don't have to really worry about the rocket. It'll fall down eventually, no big deal. This is the number of satellites. This is the number of trackable fragments. So things bigger than about 10 centimeters in size. But remember, everything's moving at many kilometers per second in orbit. So even little tiny pieces can cause serious damage. So this is just the pieces that we know about. And this is, bolts that fall off, pieces that fall, break, debris from satellites that break up, any of that. So you'll see some features in this, right? So this was an anti-satellite test by the Chinese government, the US government, and I think another country had done one previously, but it didn't leave as much debris just for whatever reason. This was a collision between two satellites, an active satellite and a dead satellite. And this was the Russian anti-satellite test just a few months ago that caused astronauts to have to shelter in place to avoid debris from that. So that then you'll notice there's like this huge uptick here. This is sometimes referred to as new space because now the number of objects being put into orbit is dominated by private companies, not by government. So that's a real change in how we're using orbit. Here's another visualization of the same data. So now looking at altitude above the Earth. So here it is as a histogram. Here it is just sort of smeared out so you can kind of get a different visual of the density. So the red points are just dead things, rocket bodies, leftover dead satellites, that sort of thing. The blue points are active satellites right now. The black points are from the Russian anti-satellite test. Guess where Starlink is? It's very easy to see on this plot, right? So all of the gray points are other debris that's going to slowly spiral inwards over time. And so all of that is going to cross through Starlink orbits. The Starlinks are on such a dense, highly dense orbit that they're constantly changing their orbit to not collide with each other. The real worry is that we could go into what's called Kessler Syndrome, where you get two satellites crash into each other, that makes a bunch of debris, then that breaks more satellites, more debris, and all of a sudden you can't use part of orbit. So it's very obvious where that will happen. If it happens, it's going to happen in this high density spot. So I want to show you a terrifying website. So this is showing, it takes a minute to load because it's an insane amount of data, but so this is everything that's in orbit over time. The color tells you what kind of conjunction is happening. So a conjunction is a close approach between two bodies in orbit. And the scale is in kilometers. So you'll see, so this is real time, this is my time, but over time, over the next few minutes, there are going to be many close passes, less than 2 kilometers between satellites and pieces of junk and that sort of thing. Like this is real data. This is not made up. This is not a simulation. This is what's actually happening. All of this stuff is traveling at 10 kilometers per second. So 2 kilometers is actually really close. And this is happening all the time. Yeah, it's becoming the 401 highway. Exactly. So, yeah, and there's not really any regulation. One thing that really worries me is, what happens when these satellites that have to actively avoid colliding with each other, what happens when there's a huge solar flare and they all go into safe mode for a couple hours, right? This has happened in the past. For sure, it has killed satellites, just solar flares and stuff. We're coming up to solar maximum in 2 years. I have asked operators at meetings like what their plan is. They do not have a plan. They are not thinking about this. Starlink actually lost an entire batch of satellites in February, just a couple months ago. because of a very small solar storm that puffed up the Earth's atmosphere just a little bit, and that caused all of them to fall back into the atmosphere. So this is bad. They are not thinking about this, and they are not required to think about this. It's they're using a shared space quite recklessly. So yeah, what's the level of risk to the International Space Station? Well, we saw from the Russian anti-satellite test that this debris it could kill astronauts easily, right? It's in the same general orbit as the International Space Station. I think the space station's a little bit lower, but like if there's a collision, everything gets spread out a little bit, right? So it could absolutely cause problems for the International Space Station. Okay, so another problem is pollution, right? So these Starlink satellites are built fast and cheap, and it's no big deal if you lose a whole batch of them, or they've got like a 10% failure rate right now, which is crazy. But they're planning to only have these satellites last for 5 years. Most satellites in orbit last for decades currently, but they're planning to do this fast and cheap and just replace them quickly. But if you look at the numbers, it's horrifying. So each Starlink satellite right now is 260 kilograms. They plan to deorbit 42,000 satellites every 5 years. If you just do the math on that, that's 23 satellites a day on average. That's 6 tons of satellites per day. I just read that the next generation of Starlink is actually more than a ton per satellite. So that comes, I did the math, it comes to 28 tons of satellite per day as they deorbit those. These satellites are mostly aluminum. So meteoroids hit the Earth's atmosphere constantly, right? Little tiny shooting stars. We get 50 tons a day from those. But they're only 1% aluminum. So what's going to happen when we suddenly start dumping tons of aluminum, literally tons of aluminum, into the Earth's upper atmosphere every single day? We don't know. There's no environmental regulation here. It's not considered part of the Earth environment, so they're not required to do environmental assessments. It's really horrifying what they're planning to do with no oversight. So yeah, that's really, that one keeps me up at night. Yeah, okay, so yeah, so it reflects sunlight and it stops global warming. Well, what happens, I don't know if any of you have read there was a really good novel by Neil Stevenson called Termination Shock that just came out, right? So talking about the idea like, well, yeah, we could put sulfur in the upper atmosphere and that would cause the Earth's atmosphere to be more reflective and it would drop temperatures. But as soon as you stop, then you get this termination shock and everything goes, like everything warms up immediately, right? So you would have to keep doing that like forever. How do you keep doing that forever? Well, it's not a solution. It's another problem on top of global warming. So yeah. Also, if we're going to do something like that, I would like it to be purposeful, not like just an accident of some other thing that we're doing. So yeah, it's not a solution. Do not think of it as a solution. It's not going to help. Okay, so another problem is the re-entries. So this is a year ago, there was a re-entry of a gigantic Chinese rocket, and there was lots of talk about like, well, where is it going to fall? And it was probably going to land in the ocean, but what if it doesn't? It could totally land on Europe or the US. Didn't quite come up high enough, a little tiny bit of Canada, you guys. But yeah, so there's no rules about that. That's fine. This is a video that was taken of a SpaceX rocket re-entry over Vancouver a little more than a year ago, right? This is what it looks like. We'll see a lot more of these happening now. And a piece of that actually made it to the ground in Washington State and smashed into some farmer's field. What if it had crashed into someone's house? We don't have legal precedent for that, except So the only time, there's some treaties, the only time that they were tested was in the late 70s. There was a Soviet nuclear powered satellite that crashed into Canada and sprayed nuclear waste across northern Canada. So the Soviet Union, according to this, these treaties, was supposed to warn Canada in advance. They did not. They then offered to help clean it up, but Canada said, no, thank you. We've got giant American radar dishes. We don't really want you to see up there. So the Soviet Union eventually paid some piddly amount of money to compensate Canada for that. But that is the only time this has ever been tested. All of the rules that were made for this sort of thing were made in a time when it was only governments that were launching. There's no rules for private companies. What happens when, not if, when a SpaceX rocket crashes into someone's house in another country? What happens if it kills someone? We don't have any legal precedent. So this is going to be a fascinating area. Space law is actually a thing, and it's going to have some really interesting, really terrifying cases in the very near future. Okay, so there's other problems too, but those are the ones I think are the most important right now. So as astronomers, I think the one that appeals to all of us the most viscerally is this, the sky is changing right now, right? So this is from this Apple Store app by Hannah Ryan. So this is my sky. He made this for a CNN interview that I had. This is what my sky looks like right now. This is what my sky will look like with 65,000 satellites. Right, this is changing right now. It is happening right now. What are we going to miss? Right, so I studied the outer solar system, so I know there was 100-kilometer wide comet that was just discovered right at the edge of detectability in the Dark Energy Survey. We would have missed that with just a little bit more noise in there, which satellites could add. The Planet 9, right? So I want to find out if Planet 9 exists or not. In order to do that, we need really good statistics. We need to know all of our biases really well. And with satellites thrown in there, that's another bias that we don't necessarily know very well. There's the interstellar objects. That's another one that's right on the edge of what we can detect. Are we going to find more of them or not? But the one that's really worrying is near-Earth asteroids, right? So there are surveys that are looking for potentially hazardous asteroids, right? This is the only natural disaster that could kill everyone on the world in one event, right? So it's really important because we can do something about it. If you discover a hazardous asteroid far enough in advance, you can change its orbit just a tiny bit and it will miss. If you discover something like the Chelyabinsk meteorite that injured like hundreds of people because of broken glass. It didn't actually do any direct damage, but the shock wave injured tons of people. If you had known about it in advance, you could have told people, like, don't stand by the window, right? Even if like 20 minutes warning, that would have been enough, right? So, finding these early as possible, and that relies on having really good observations close to sunrise and close to sunset. That's when it's most important, and that's when the satellite light pollution is at its worst. So this will make us less safe from potentially hazardous asteroids. Okay, so what are we already doing about this? This is a huge list. I don't expect you to read the whole thing. Just to, there are a lot of professional astronomers and amateur astronomers who are working on this. There's software, right? We're coming up with ways to remove satellite trails from images. It's not perfect, but it's better than nothing. There's working on software ways to close the shutter quickly so that you miss the satellite going through, observing satellites to make sure they're as faint as they're supposed to be and on the orbit they say they're on, trying really hard to keep talking to satellite operators. I personally am not sure that's working very well anymore because they keep saying they're going to change things and then they don't. But we need to continue to have this dialogue where we have nothing. They have all of the money and all of the power in this relationship. So we astronomers really just have to be polite and hope they listen to us. It's not good. I had, so Aaron Boley, professor at UBC, and myself had a consultation with a whole bunch of Canadian government officials, which was really interesting. I don't know how much it helps because it can't just be one country doing it, right? So if Canada says, oh, well, you are making it harder for astronomers in Canada, so you have to pay this fee to astronomers to, you know, make up for the fact that they have to spend more time to do the same research now. Then Starlink could just turn around and say, well, we don't really need to broadcast to Canada anyway, so bye. And then we get all of the downsides and none of the benefits, right? So that's the worst case scenario. So it has to be international regulation. So there is a new International Astronomical Union Center that we, so I'm sort of vaguely involved in this. It's not clear to me what the structure is actually going to be yet, but the important part is that it's going to, one of the main things is going to be a website where we can tie together everything, right? You can go here to talk, to share your observations, to talk to other people about ways to mitigate this, to talk to people who are doing outreach on this, and policy, right? So it's supposed to be a place to connect people. So take a look at this. It is ramping up right now. I think it has officially started, but it might not get full funding until October. So it's ramping up this summer. So keep an eye out for that. There's lots of places for amateur astronomers to be involved in that. Okay, so what can you all watching this do? So these giant billionaire-run companies will only respond to international legislation, which is very slow. There are talks happening right now at the UN level, but it will not happen fast enough. The other thing they will listen to is consumer pressure, right? They are profit driven. If their consumers are demanding that they pay attention to the darkness of their satellites, they will have to do that. So I'm going to recommend, if you have alternatives, do not use satellite internet, especially not Starlink. But I realize that that Starlink is the only viable option in a lot of places, right? And this is because of lots of neglect in infrastructure development, right? So like where I live outside the city, it's very easy for me to connect to an electric line, to a telephone line, even to a natural gas line if I want to. It's right here, but I cannot connect to broadband, right? That is something that has not been funded as well as it should be for rural and remote customers for decades, right? Like it's like 20 years behind everything else. So talking to your government officials about this, tell them to support other ways, right? So I'm fortunate enough, I have a cell tower network here that I can access, but it would be great if I had broadband instead. So tell other people what's happening to the sky. Most people that I talk to have no idea, but it is changing. There was a survey done earlier this year of just random Americans, and they were asked if the use of orbit by satellite companies should be regulated, and like 70% of people said yes, which is amazing because 2 years ago most people would say, what? What does that even mean? But most people are hearing about this now. So keep telling people what is happening, and show people the sky. I know many of you do great outreach. You show people the sky with your telescopes. Keep doing that. And get out and enjoy it yourself, because it is changing right now. So a couple of quotes, I'll just, one of them that is really powerful from the SatCon 2 report. We are on the threshold of fundamentally changing a natural resource that since our earliest ancestors has been a source of wonder, storytelling, discovery, and understanding of ourselves and our origins. We transform that at our peril. We are transforming it now. So it's so important to protect all of this culture and traditional knowledge that's wrapped up in the sky, to not drown it behind man-made satellites. This is happening worldwide without consent from the vast majority of the world's population, whether or not they can access this service. And it shouldn't have to be an either or, right? With proper regulation and better engineering, right? Like this is something I never thought I'd have to say to SpaceX, which has fantastic engineers. But if they make this a priority for their engineers to make their satellites darker, I have no doubt they can do it. So with proper regulation, better engineering, and cooperation between satellite operators, so they don't need so many satellites, we can still have astronomy and global internet. So, but we have to fight for it. So thank you for listening. Thank you for showing people the sky. And I will go through and answer your questions now.
I've got a sort of a controversial but yet optimistic question.
Okay.
I mean, yeah, what you outlined, there's all the bad things are going to happen. But I view that as sort of a short-term technology problem, because what they're trying to do is deliver, you know, internet to remote sites.
Yep.
In 25, 50 years, there'll be another technology solution, and the satellites will disappear because they're going to be too expensive.
Unless we go into Kessler Syndrome. And then there will still be bits of satellite in orbit for 100 years before they're pulled out of orbit by the sun. So, or by the sun cycles and the Earth's atmosphere. So that is something that we really do have to avoid. If we go into Kessler Syndrome, we lose all of our satellites. Like most of them will become non-functional because of collisions. And that is something that, like, what's going to happen if there's a collision between two satellites? Like legally, there's no precedent for it. So SpaceX is just going for it, right? Like they don't care because they don't see any deterrent against that, right? So I do agree with you. I think that it is temporary technologically, but I think that there are very big problems that could result from the reckless use of orbit, which is totally what's happening now. And those won't just go away.
Well, then we Earthlings will just have to have staycations. We're not going to go anywhere. That's all.
Yeah, yeah.
COVID for the rest of our lives.
Yeah.
No. You only have to wait about 50 years till they deorbit.
No, you see, the thing about SpaceX or any satellite system is one of the main advantages is you get up into a vacuum and you can use lasers to communicate. You don't have to use lasers, but the speed of transmission is faster than on Earth. And if the speed of transmission is important, like for financial transactions, it's extremely valuable. So this is going to happen. We need to, if we want to avoid this, we need to find a way to control it. But I don't know, there isn't a body.
It's called fiber.
Well, no. Fiber's slow.
We're going to fiber the world.
No. Fiber is slow. If you ran a fiber between 2 points, you can still go faster as long as it's over about 1,000 kilometers. You can still go faster by going to orbit and use a laser through space.
Are milliseconds that important in financial transactions?
They ran a $300 million fiber in the United States quietly because it gave them, I think, 40 nanoseconds. A 40 nanosecond advantage turned out to be worth hundreds of millions of dollars.
Yeah, and I keep hearing this from satellite operators too. Like that's the latency is what they, because we hear, we talk, well, why don't you put them at higher orbits? Put them at geosynchronous orbit where we can't see them, right? And they say no latency, you can't do it. Yeah. So that's what's driving this.
Yeah.
There are some questions in the chat. We go through those. So a couple of people have asked regulation. So when we talk about, Alan, this came from you and another person. What do you mean by that? Regulated by what body? The UN? Yeah, Alan, do you mind elaborating on your question?
Yeah, what I mean is, okay, let's say we want to go the regulation route. You obviously need to get every spacefaring nation to agree, because China can just throw them all up there.
Yeah, totally.
Russia could, right?
Yep.
But India could, South Korea. Anyway, so it has to be a worldwide body, or at least of spacefaring nations, and you'd have to get them all to agree and agree on limits.
Yes.
And just like with nuclear weapons, it's tricky. So, and it has to happen very, very quickly, because SpaceX are already going crazy. So we've lost. You should have had this talk 10 years ago.
Yeah, yeah. Oh, yeah. SpaceX wasn't launching satellites like I think this surprised again. It's like the LED. It's exactly the same kind of this leap in technology that you know, people who had been fighting light pollution for decades suddenly had, like, it's so much brighter. Oh no, right? So this is the same thing. Like astronomers knew that this was, you know, like I had heard little, you know, whisperings about it for at least a couple of years beforehand. And then all of a sudden it was happening. And I was like, oh, wow, that happened really quick. So it's, yeah. So we haven't lost because there are many options for, right, like anything that makes the satellites, makes us use fewer satellites will solve all of these problems, right? If there is some better engineering to use fewer satellites to reach the same number of customers, or to share infrastructure is another thing, right? Like it used to be every cell company had their own cell towers, right? But now they all share, right? So why can't we do that with satellites? If there's a hard limit on the number of satellites in orbit, I bet they'll figure out how to share, right? So that's there are options still.
They may have data throughput problems, and that's why they can't share.
Oh yeah, I mean, there's lots of reasons right now with their current setup that they can't share. But like they if they're forced to, they will figure out how. That's what engineers are good at. They're good at, like, if you give them a hard constraint, they will figure out. Like SpaceX engineers are amazing, right? Like they land rockets on drone ships in the middle of the ocean. They are incredible engineers, but they don't have this constraint right now because they don't care, right? Their company doesn't care about that. But if they're given that constraint, I bet they'll figure out a way to do it.
So, the continuation of that conversation, what are we hearing at conferences? You mentioned you were going to conferences. And what are the responses, you know, what responses are you hearing from the private companies at this point in time?
So, okay, so what I've heard, so this is my personal opinion, is the people that, so it seems to me like a lot of the companies, so they do send representatives. There's been representatives from SpaceX, from OneWeb, and from Amazon at several of the meetings that I've gone to, which is great. Like, I really appreciate that. But it really seems like the people that they pick are just like, they just sort of randomly say like, okay, you get to go talk to the astronomers today. And it's not necessarily someone who knows a lot, who can answer a lot of our questions. So a lot of times as astronomers, we'll ask them something and they have no idea, or like they don't even know who to ask, right? So it's not, they're not putting a whole lot of effort into engaging with astronomers. They're just doing the bare minimum, which is better than nothing, but not a lot better than nothing. So, and yeah, so they are talking to us. But yeah, again, it hasn't been super productive. There's been a lot of, like, we tell them like, this is really important. You need to make your satellites below magnitude 7. And they say, okay, we will do that. Haha, just kidding, we won't. Right? It's really, really frustrating. And there's nothing we can do about it, right? Like we have zero power. They are led by literally the richest people in the world. And so we have piddly little tiny grants, and that's it to fight this. So I think we're starting to get more organized, but they're way more organized and way more lawyered up and have way more money than we ever will. So it's really hard to fight that. So consumer pressure, right? Tell people what's happening, and tell them to tell their providers, tell their governments what is happening, and that they care about the sky, which is hard. Everybody's overloaded right now, right? There's so many things that we need to be advocating for with our government. So it's really hard.
Okay, that's great. Another question that comes to us is, are there calculations predicting when in the future the collision chain reactions might occur?
Oh yeah, there's definitely, like, the plots that I showed you are from a paper that has a calculation on that. That was predicting, I think, 5 years out, but it all depends on how good, right? So right now it is entirely based on SpaceX, right? SpaceX effectively controls orbit. If you look at like the number of conjunctions between satellites, it's like more than half of them are between Starlink satellites, right? So if they mess up, they make a mistake, it's over, right? Like we're in Kessler Syndrome because they're in that super dense orbit. So, I mean, you know, they have a lot of incentive not to do that because that's their entire business plan gone, right? But it's still like, I know of a lot of companies that have screwed up a lot of things when they thought that they had it under control, right? With no regulation. So I am not confident that they have this. But yeah, it could happen anytime, really. And you know, one badly placed piece of space junk that's 9 centimeters across that we couldn't track could end it all anytime. We saw that plot of how many conjunctions are happening in the next few minutes. That's happening all the time.
Well, that's scary at the same time, isn't it?
Yeah.
Any hope that economics will kill it? The fixed costs go up with every satellite. However, the market is relatively fixed in time. This comes from Keith.
Yeah, that's a really good question. And that could happen. I mean, so again, it sort of depends on like, I'm sorry, I missed whoever made the very first comment was talking about, you know, the temporary nature of this, right? Like if suddenly there's a lot of broadband access and that's cheaper and faster, then people are going to go with that instead of satellites, right? Like the Starlink access is not cheap, but you know, those of us who live in rural places, it's about the same cost as what I pay here for my internet, right? So like my neighbors use Starlink. I know it's a viable option here now. So it is possible. I saw a paper that looked at how many Starlink users can you have in a small area and still have fast internet, right? And it's really, really low density. It's like less than 1 person per square kilometer or something like that. If you get higher densities than that, like in a city, Starlink is not viable for a city. So I don't know, there's a lot of hype. There's a lot of, you know, ego worship culture that goes along with Starlink and any company with involvement from the person whose name I won't even say. So I don't know, how do you get around that, right? Like, I don't know. Economics is, I'm an astronomer, not an economics expert. So I'll stick to physics, it's easier. It doesn't involve humans as much.
That's a surprising number. I didn't realize it only serves one.
Like that was a paper that I saw that was looking at this from a totally independent view. I'm sure that they would say that they have a much higher density that they can support, and maybe they do, right? Like I don't, yeah, but I thought that was a very interesting result.
This next question comes from Arsalan. Did the proliferation of satellites affect radio
Yes.
astronomy as much as visible light astronomy, or are they less impacted?
Yeah, and that's something I keep meaning to add into this talk, but so I am very biased toward optical and infrared wavelengths because that's what I think about all the time. But yeah, radio astronomers are going to have a hard time of this too. Like the frequencies that are used for satellite downlinks and uplinks and everything now are already totally closed to science, right? There's too much noise from that. If ground-based radio frequencies are allocated to increased numbers of satellites, then there will be more of these more chunks of frequency space that radio astronomers cannot study, right? Because they build these telescopes in radio quiet zones, right? Like the Dominion Radio Astrophysical Observatory in Penticton is, they have like signs on the road, turn off your cell phone, right? Like it's serious. Like you can't, there's no microwave ovens on the campus, right? It's very serious how radio quiet it is there. But now there's satellites flying over it all the time. And talking to radio astronomers there, the thing that's actually going to cause them the most problem is reflections of ground-based radio emissions off of the satellites, which is something I'd never thought about. But like you get that with jets flying over too, right? It just depends on, and that'll be worse close to the horizon where there's more satellites, right? So, you know, all my models were bright satellites overhead, but for radio astronomers, it's bright satellites all around the edge. And that's, you know, reflecting radio emissions from cities and stuff that are way over your horizon. So I thought that was pretty fascinating. So it will be a serious problem for radio astronomy also, in a different way.
Fascinating. There's a last question
Oh,
for now anyway. Are potential astronomical occultations any sort of problem, especially for some of the large survey telescopes? This comes from people.
That's a good question. So so in my paper, we did a quick like order of magnitude calculation to figure out, because so a satellite passing in front of a star, it happens very, very quickly. It's a fraction of a second that the star is occulted for, covered up for. But if there's 42,000 satellites or 65,000 satellites, that will happen a lot. And there's a survey called TAUS, which I don't remember what it stands for, but they're looking for Oort cloud objects, so icy bodies in the distant outer solar system, to pass in front of stars and cause them to blink out very briefly. And the signal is actually almost exactly the same time scale. So there's a huge new telescope that they're building in Mexico for this project, and I'm not involved in that team, and I don't know if they've thought about this yet. But if there's 65,000 satellites, they will not get a signal from Oort cloud objects that's stronger than from satellites. So yeah, it'll affect little bits of astronomy. For like exoplanet transits or something, it's such a short occultation that it's not going to cause any problems. But there might be other areas of astronomy. That's just the one that I thought of quickly. Wow,
that's amazing. A question for you around the launch of rockets too. So how do they time the rockets if the satellites are so dense?
Yeah, that is a very good question. I have no idea how they coordinate that. Another one that's so like astronomers who use laser guide stars for like adaptive optic systems on like Keck or Gemini, it used to be that they had to call Space Command or something, right? There was like a special red phone at the observatory to call up Space Command, and they'd ask like, are there any satellites? Can we turn on our laser? And they had to call Space Command because there's like classified satellites. So they would tell them yes or no. Now it's going to be impossible. There's always satellites. So there's been some jokes among astronomers who do this, like, well, what if we hit them on purpose? And I don't think it would actually cause any damage, but it's definitely something that has changed. So yeah.
Wow, amazing. Lots of things to think about here, Dr. Lawler. Definitely eye-opening for me personally anyway. I'm sure other folks have lots to think about. So I personally thank you for your time today. Really excellent talk. Thank you. I'm going to hand the reins back over to Randy and Alan. And again, thank you for your time today.
Cool. Thank you for having me. Thank you all for listening. If you have other questions, feel free to send me an email. And yeah, thanks.
Yes, thank you very much, Dr. Lawler. This has been a very entertaining and informative talk, and I think it's just the beginning of a long process. I guess we're going to continue to follow your work, and maybe down the road we'll reach out to you again for an update. So thanks again for everything.
Thanks. Okay, thanks everybody. I guess I will sign off.
Take care. Yeah, it's
nearly
dinner time, so
yeah, gotta get my kids to bed. So bye, everybody.
Take care. Thank you, and thank you, Swapna, for setting up this talk. This has been awesome. I've been watching Dr. Lawler's Twitter account lately, and she essentially has been going through like 14-hour days of teaching and reacting to interviews and whatever. So I think we're very fortunate to have her time tonight. So thanks again.
Thank you.
So future items. We have a Riverwood night coming up on June 8th. It's going to be on a Wednesday because of a previous commitment that Riverwood has set up on the 7th. So we will be calling for volunteers for that. And we have a potpourri coming up on the 10th. But the main item that's coming up in the near term is our picnic. And after a 2-year hiatus, we're looking forward to that. Alan, did you want to say a few words? You said a few words at the beginning about that. You want to remind people?
Yeah, as I said at the beginning, I will be sending out another notice to, we've had good response, but I'm hoping to get more. On my next email, I will emphasize the free nature of the picnic. Perhaps people missed that in the original notice. I'll emphasize the ice cream truck that's coming by, just in case anyone missed that. That's another fun thing. And we have activities planned that we're not going to reveal yet because they're going to be just too much fun, and I'm worried about hordes of people attending. I will be sending out an email on Sunday regarding, we don't anticipate the need for as many volunteers as in the past because we have decided to try subbing it instead of barbecuing to try and get more people actually able to enjoy the picnic as opposed to sitting away slaving on a barbecue somewhere. So I thank everyone who has registered so far. And if you haven't and you're on the call, register.
And by the way, that's only members, right?
Only members and their families.
And their families.
Yep.
And there is a rumor that there will be the first ever Mississauga Center RASC trivia contest.
That's just a rumor right now.
That's just a rumor.
Yeah.
So if that rumor is true, then people better brush up on their astronomy, especially those extremely interested in cosmology, John Marchese.
What's cosmology?
Thank you, God. Thank you very much. Bring all your dark matter and we'll pass it around. No, we're going to try to have a little bit of entertainment. We'll also have the solar telescope, which now can look through thunderclouds. So we're going to give that a shot. Hopefully not.
Yeah, I will be asking for appropriately equipped telescopes, assuming the weather's good, so that we can supplement the view through the solar telescope.
How does that work?
With a solar filter on them.
Oh, okay.
Sorry.
That sounds good.
Okay.
Great. So thank you, Alan, for setting that up. Later in June, we will not have a speakers night on the 24th because it is the first night of the General Assembly, which is another virtual General Assembly, and the lineup looks excellent for that. So if you haven't signed up for that, please sign up and buy your tickets. And again, if you have not registered for the picnic, please do. Alan, do we bring our chairs?
By all means, feel free to bring chairs. However, the picnic spot has a relatively large covered area. It's about, I think it's probably exactly the same dimensions as the covered area at the original site that we used to go to. So it seats probably, I don't know how many you figure it seats. It's pretty big. And there are picnic tables under it. It's right by the creek that runs through there and there's an iron bridge. It's really quite scenic. It's in the same park, obviously. It's just right at the end of the, if you continue past, if you've been to previous ones, if you continue past where we parked for the first one, right to the end, there's a circle. And it's, if you park right at the end, you just enter where the washrooms are and past. So I do not believe you will need chairs. I will put anything that I believe we need. We're going to need something on the order of 6 to 8 coolers. We personally have a couple, and I've had comments from some people that they can bring some, but I'll be putting out a request for those sort of things, and then I'll indicate a follow-up email, personal emails, whether or not you should bring them.
It'll be great opportunity to just see everybody again.
Oh, Lord, yeah.
Okay, thank you very much. Any input from our participants before we sign off? Any questions? Thanks again to Swapna for setting up this excellent talk. So the program committee will go on hiatus through the summer. So if you have any suggestions for speakers, please let us know. I do continue to try to get input from the university on when we can return, and I have not had any success. So I'm actually going to ramp it up a little bit with a phone call next week. So I'll let everyone know what I hear. So thank you, Alan, for hosting. I apologize for my email difficulties this week. I heard from a whole bunch of interesting people replying to that hacked email. So it's nice that everyone's out there, but I do apologize for that. And Rogers tells me they're working on the problem as we speak.
I do hope that your niece got her Google Play card.
I didn't hear about that one.
Yeah. That's what they were arguing about. It was interesting. It was, well, they did a good job on it.
Wow.
Yeah.
All right. So if that's it, Alan, I'll let you sign off for the evening.
Okay. Well, thanks for everyone who attended, and we'll see you probably for the first time at the picnic.
Thank you.
All right.
Bye, everyone.
Then.
Take care, everybody.
Bye.